Okay, welcome, ladies and gentlemen, to section 1.5, our introduction to complex numbers. We are going to learn today how to add, subtract, multiply, and divide complex numbers, and division being the most complicated version of it. So let's go ahead and first just look at a definition of what's called a imaginary number, or also called complex numbers. The imaginary unit I is defined as the square root of -1, or in other words, this little statement here, the square root of -1 is defined as the letter I. All complex numbers can be written in the form a plus bi, where a is the real part and bi is the imaginary part. Things that you would end up seeing for imaginary numbers would be something like this. If I said the square root of 4, we know that this is 2. However, if I was to take the square root of -4, in this case, because it's negative, the square root of negative numbers give me the imaginary, and therefore it would be I. So the square root of -4 is 2i. If I was to take the square root of -32, and if I was to break this down into the numbers that I'm going to try to simplify, I know that it's -1 times 16 times 2. I know the square root of 16 is 4. I know the square root of -1 is I. And I'm left over with a square root of 2. So the square root of -32 is 4i radical 2. So you notice if you take the square root of a negative number, we can get what's called imaginary now. If I was to write 2i as a complex number in complex form, there is no real part to 2i, so it would just be 0 plus 2i. Well, a plus bi, it could be something like 3 minus 2i, 3 plus 2i, anything like that. Okay, let's go ahead here. Complex numbers. If two complex numbers are said to be equal, that means that the real parts are equal and the complex parts are equal. Or in other words, A equals C and B equals D. And somewhere this would come up is if I had 3 plus xi equals y minus 2i. If these two complex numbers are equal, that means 3 has to equal y, and -2 has to equal the x. So we can solve for x and y in a given question like this. If you were to add or subtract two complex numbers, you would combine the two real parts together. So notice here we get a plus c. So if we have two complex numbers, a plus bi and c plus di, we would combine our two real parts, a plus c, which would get this part, and we combine our two imaginary parts, b plus d times I. Multiplication, if you were to notice that you have two terms here and two terms here, if you are multiplying, it's going to be just like FOIL. So in this case, if you were to multiply 2 minus 3i times 4 plus I would FOIL. 2 times 4 is 8. My outers makes a positive 2i. My inners make a minus 12i. And my last makes minus 3i squared. So here we get, if we were to just finish like this, 8 minus 10i minus 3i squared. But here's the problem. Because the square root of negative 1 is equal to I, if we were to square both sides, I squared is equal to negative 1. So it's very important that we remember this. It's a very big piece because right here, I squared makes negative 1. So we get 8 minus 10i plus 3 because it's a minus 3 times a minus 1. And therefore, this becomes 11 minus 10i, and then we are done. Remember, you're not allowed anything more than I to the first power. Okay, division. Division is a little bit more funky than that. If you were to take a number or whatever the numerator is, it doesn't matter, and you divide by a complex number, you must multiply by what's called the conjugate. You might remember this from Algebra 2. The conjugate of a plus bi would be a minus bi. When you multiply by conjugates, the I will cancel. Sorry about that. So if I did 3 divided by 2 minus I have to multiply by the conjugate over the conjugate because this is like multiplying by 1. In the numerator, I distribute and I get 6 plus 3i. In the denominator, I need to FOIL. I get 2 times 2, which is 4. Notice here I get a minus 2i and a plus 2i and a minus I squared. So my numerator is 6 plus 3i over 4. Well, this goes away with this. And minus I squared. I squared is negative 1. And therefore, minus a negative 1 makes a plus 1. And my final answer would be 6 plus 3i over 5. And that would be done. If we were to try something else, if I did 2 plus I over, let's go 3 minus 2i. In order to divide these two numbers, I need to multiply by the conjugate. Since now I have a complex number in the original numerator, I need to FOIL. So I get 6 plus 3i plus 4i plus 2i squared over 9. You don't have to write these if you don't need to. The plus 6i minus 6i and a minus 4i squared. So my numerator becomes 6 plus 7i minus 2 because of the I squared. And this becomes 9 plus 4 because of the I squared over here. 6 minus 2 is 4 plus 7i all over 13. And there we go. You are completed. All right, so the last thing that I want us to pick out here is the pattern that occurs with the imaginary numbers. If you were to look at the powers of an imaginary number, I to the first power is equal to I. We should understand that. I to the second power is equal to negative 1. I to the third power would be like multiplying I squared by another I, and we'd get negative 1 times I, which makes a negative I. If we go to I to the fourth, That would be like multiplying I to the third by another I, and we get negative I squared would make a positive 1. If I had like negative I times I, I'd get negative I squared, which is negative 1, therefore it's plus 1. Well, I to the 5th would just be tacking on another I, so I'd take 1 times I. Well, that's just I. And if I continue here, some of you might be seeing this pattern already. If I multiplied by another I, I'd get I squared. Well, that's just negative 1. If I multiplied by another I, I'd just get negative I again. If I multiplied by another I, I'd end up with that positive 1. So what you'll notice is if I just continue this pattern, oops, that's a negative 1. And then negative I, and then positive 1. You notice this pattern continues, and it's every 4 powers. And the reason I say that is because I can start to ask something like this. What would I to the 21st power be? Well, I know that this is I to the 4th times I to the 4th, if you want to go this far. I know that there's 5 groups of 4 inside this 21. And each one of those groups of 4 is a 1. And you're left with a single I left over, and therefore the answer is I. So I to the 21st power is I, because every 4th power goes back to a 1. Well, that means if I think about it a little bit differently, I to the 27th is like I to the 24th, that's a multiple of 4, times I to the 3rd. Well, every multiple of 4 is going to be a 1 times I to the 3rd. Well, I to the 3rd is negative I, and therefore my answer is just negative I. So I'm looking at how far it is from a multiple of 4. So I could ask something like I to the 2002. I just look for a close multiple of 4. Well, I know 2000 is a multiple of 4. And I to the 2nd. This to the 4th power thing is just a 1. And I squared is negative 1. And therefore, I to the 2002nd power is negative 1. It's kind of cool little things you can do, little quick tricks you can show your friends, right? Okay, that will finish us off for the afternoon. Here is your assignment. Please start on this and get all of your previous assignments completed so we can get all on task and all in the right place when we get to class tomorrow. I will see you guys later.